A programmer might adapt permutation and combination calculations in a daily life problems. You are expected to apply these formulas in some platforms such as hackerrank. Permutation, or shortly MPR, is equal to n factorial divided by n minus r factorial, and combination, or shortly NCR, is equal to n factorial divided by n minus r factorial and divided by r factorial. We can express combination formula in a simpler way. It's also equal to MPR over r factorial. Let's set initial values for n and r pair, and let's say n is equal to 5 and r is equal to 3. I'm going to import math library to handle factorial calculation in a simple way. Let's define a function to calculate the permutation MPR, and it expects n and r pair as input. Remember the formula of MPR. We need to calculate the n factorial first. We need to call math.factorial and pass n as input, and it's going to be divided by the factorial value of n minus r, and result will be returned. Let's see the result of this function for our n and r pair. That's 60. Similarly, we can define a function for NCR, and this expects n and r pair as input as well, and the result is going to be math.factorial of n is going to be divided by math.factorial n minus r times math.factorial of r. Let's see the result for NCR. I'm going to pass n and r pair as input here. It's going to be 10. I'm also going to import the time library here, and I wonder the processing time for those functions. Tick is going to be the starting time, and that's going to be the result, and talk is going to be the finish time. And now we can return the result, and before returning I can pass talk minus tick seconds. I'm going to apply same logic here. As seen, both permutation and combination calculations last almost 0 seconds. It's very small times because the input pair is very small values. As I mentioned, input pairs are very small for our tests. What about we will increase the value of n and r pair? For example, let's set 5 million to n, and let's set 10,000 to r. It throws an exception, and it says that it cannot handle to calculate very large values. The workaround is easy. We can use double dividing symbols here. By the way, result of the both permutation and combination for very large values will be very large values as well. That's why I don't want to print the results here and assign this line to P and assign this line to C. I have run the both calculations for permutation and calculation, and it seems that it will last long. Calculations are over. As seen, the both calculation almost last 5 minutes. That's very long time. Even though this program will pass the result test, it will fail the time test. We have to hack the program and find a workaround, because those times are not acceptable. Let's consider this permutation calculation for a small numbers, for example 5 and 3. It's actually equal to 5 factorial over 5 minus 3 factorial, and this is equal to 5 factorial over 2 factorial. Notice that we can express 5 factorial just like that: 5 times 4 times 3 times 2 factorial over 2 factorial, and 2 factorial exists in both dividend and divisor. That's why we can simplify the equation just like that: 5 times 4 times 3. Based on this rule, I'm going to define a new function, and its name will be fast NPR, and N and R pair will be its inputs again. In this function, I'm going to build a for loop for I in range from n to n minus r, and decrease its value one by one. Set the permutation's initial value is 1, and in this for loop I'm going to multiply the permutation value to I, and this function will return the value of P. Let's test it. Call fast NPR and pass the previous test set 5 and 3, and it's 60 again. Remember the regular NPR function. The bot function will return 60, but here I also wonder the processing time. Set the starting time in the tick variable, and after the for loop set the talk as adding time, and here let's print talk minus tick seconds. We have checked the result, that's why I can remove this block and pass the original N and R pair as input. Remember that N and R pair are 5,000,000 and 10,000, and the processing time was almost 5 minutes in the regular implementation. And let's see the result time for the new function. Sorry about that. That's going to be fast P, and it lasts less than a second. That's amazing because it's almost 600 times faster than the previous implementation. And let's check the result. Fast P is equal to P. That's true. I mean that the both fast NPR and NPR functions return the same result, but fast NPR function is much faster than the regular implementation. Now we are going to do some faster calculation for combination. I'm creating a function named fast NCR, and this expects N and R pair as input as well. Remember that it's actually equal to fast NPR for N and R pair over method factorial r fasti is equal to that, and return fasti as an output. And also let's calculate the time. And here I'm going to calculate the talk minus take seconds. Let's call fast answer and pass and r pair. Actually, that's because of the very large values. I modified the division symbol with double symbols. That's going to be fasti. The first time comes from the permutation calculation, and the second comes from the overall fast NCR function. And SD, it lasts less than a second. Remember the processing time for the legacy method, that was 5 minutes, almost 300 seconds, and this means that this approach is almost 300 times faster than the legacy approach. And also let's check the result. Fasti is equal to C. Sorry about that, I need to check just like that. True, this means that the both traditional approach NCR and the this hacking method fast NCR returns same result, but fast NCR returns very faster way. These new approaches will pass time tests as well. So we have found a hacking method to calculate combination and permutation in a faster way. Thank you all for watching, and see you next time.